So the next talk, Michelle Worrell-Carrillo is going to present PharmGKB and PharmCat, and it looks like technology is working. Michelle, do you want to go to presentation mode? We see the
presentation mode, yes.
And we hear you.
Sorry about that.
That's okay.
You can hear me?
Yes, you sound great.
Good. I don't know how to swap out my presentation mode.
Or just put it in presenter.
Why can't I find it?
Click bottom right there.
Here we go. Thank you. Thank you. It's being slow. There we go. Do you see it now?
We see it great. Go for it.
Okay. Well, thanks so much. Thanks, Marilyn, and thanks to everybody there. I'm so sorry I can't be there in person. I really wanted to be, but I'm happy to be able to talk to you today virtually. I'm going to be talking about PharmGKB and PharmCat, and like Andrea with PharmVar, I'm going to be assuming that you pretty much know what these things are and tell you about what's going on and what's new. But before I do that, I wanted to just take a minute to thank our team. Without them, all this work for PharmGKB and PharmCat would not be possible. And as you saw, they do a ton of work on CPIC as well, and also PharmVar. And so our scientists are terrific. Li Gong and Katrin Sangul are working constantly on between PharmVar, PharmGKB, PharmCat, and CPIC. Ingrid Kessler, Binglin Lee, Caroline Thorne, who's our only person there right now because she lives in Philadelphia, and Rachel Hood are our scientists, and our developers, Ryan Whaley, Mark Boone, and Issa Reinhardt, make everything possible. So, and of course the rest of our team as well, but I just wanted to give a shout out to our scientists and our software developers because they are really the heart of all the work that I'm going to show you. So this is the PharmGKB website. This is the homepage. PharmGKB is a centralized resource that collects PGX knowledge from a variety of sources, including the peer-reviewed published literature. We use text mining and machine learning approaches to try to automatically identify articles that are then manually curated. But we also leverage information from a lot of different sources. We work very closely and tightly with PharmVar and CPIC, and I'm going to talk about some of the major sources of information in my talk here. So to start out, I just wanted to say PharmGKB is very heavily used by users on every continent except Antarctica, I guess. So we have very many eyeballs on the site every month. These are about monthly averages. Right now, we have variant level summaries of PGX associations, over 27,000 of them, covering over 800 medications, over 8,000 variants and haplotypes, and that information has been gathered together from over 18,000 different papers. And we use those variant annotations to create what we call clinical annotations, which are like summaries. We have over 5,000 of those right now, encompassing over 3,000 genes and haplotypes and variants, and over 640 medications. And if you're wondering why fewer of those, well, first of all, because we're aggregating the variant annotations, number one, together to make them summaries. And number two, a lot of the literature out there might publish on an association that we can't find has ever been replicated. And like I said, those clinical annotations are summaries. So we're very busy. Our scientific staff is constantly curating new papers. We also curate regulatory approved drug labels, including those from the FDA. We've curated over 1,000 labels total, over 450 from the FDA so far. We also manually annotate Pharmacogenomics guidelines. Many of you know that we have CPIC and a Dutch working group specifically covered, but also guidelines from other sources as well. And for the CPIC ones, we try to have videos. Sometimes we're a little bit behind on how many videos we have for the guideline coverage there. But we have videos and interactive ways of looking at the annotations from CPIC and DPWG. It's kind of hard to count those annotations because they're published in manuscripts as groups, and on PharmGKB, we have them in gene drug pairs. So I'll just say there's over 190 drugs covered by PGX annotations. And we currently have over 240 pharmacokinetic and pharmacodynamic pathways available on PharmGKB, all created by our scientific staff based on peer-reviewed literature evidence. So talking about what's new, I'm going to go into that next. Right now, like I said, curating literature is a large part of what we do. In the past year, our scientists have created about 1,000 new variant annotations, 40 new clinical annotations, about 40, but there are many, many clinical annotations that have been updated by this new literature. So if you think about these clinical annotations as summaries, as we gather more and more evidence, there's more and more replication studies or more big studies looking at what's the power behind some of these associations, we're able to bolster our existing clinical annotations with more evidence. We also spend a lot of time staying current with updates from CPIC, from DPWG, from PharmVar, all those things that you've already heard about, all those new guidelines Kelly talked about, all the new stuff that Andrea talks about at PharmVar. For example, all that NAT2 stuff, our Dr. Songol has been spent hours going back and updating all the annotations on PharmG KB using that new nomenclature, the new star allele assignments for NAT2. Of course, publications up to date, up to this point in time, have all been using that old star allele nomenclature. Someone has to go in and say, okay, in this paper they were talking about that, but now we're calling it this. So hours are spent there. And she also helps coordinate the PharmVar updates along with our developers, Mark Moon and Ryan Whaley, from PharmVar. Every time PharmVar has a release, come out with new alleles in 2D6 or whatever gene. We take it in, she oversees that, double checks it, and shares it with the CPIC database, PharmCat, et cetera. So that's a lot of time goes into that. But this past year, we've done a pretty big overhaul on all of our FDA label annotations, partially in preparation for the inclusion of this information and some of the features that I'm going to talk about in a little bit. But I just wanted to give you a little bit of a heads up on the changes to our drug label annotation. So we know that the FDA's biomarker table is huge. There's over 500 entries on that. And it's not clear based on that table which entries are clinically relevant, and many of them are not. So when we started curating the FDA labels over a decade ago, there was relatively no dosing information on the labels. People really back then wanted to know if they needed to test a certain gene before prescribing a drug or not. That was the big question. Am I supposed to be testing this gene before I'm allowed to prescribe a drug? So we went through and we created this testing required and testing recommendation tags, which are pretty self-explanatory, except if you've read those drug labels, you know that the FDA can hedge a lot. Some of the wording is a little bit soft, we shall say. So some decisions have to be made about, are they recommending testing or not? So there are definitions of what kind of language we consider to be testing recommended on our website if you go to that URL. Actionable, there are some labels, though, which acknowledge that gene was, for example, a metabolizing enzyme and could lead to altered concentrations in certain patients, even though the label didn't say anything about testing at all. A clinician could use that information, perhaps, to prescribe a different drug if they knew a patient could be affected. So we created this term, actionable PGX, to tag those labels. And then we created the informative tag for all other labels, because there are some that just don't really talk about any of that, but still on the biomarker list. So these were our creations. I think that they have been pretty well adopted. People do talk about these levels for labels a lot. However, over time, things began to change, and more actionable information, in the absence of talking about any testing, is starting to appear on more and more labels. So to address this, we highlight if a label gives any actual genotype or phenotype-based prescribing guidance. So we give this prescribing info tag and say whether or not they're talking about changing a dose or using a different drug. And so, of course, if there's prescribing information on a label, it has to be one of these three levels, right? But not everything that has actionable under our definition would actually have prescribing information. I'll talk about that in a second. So these tags have been around for a few years now. Recently, we added this other guidance tag because there are times when the label may say something like, you want to monitor poor metabolizers more, something like that. It's not altering a drug or dosing info, it's other guidance. So sometimes, like I said, the label won't go so far as suggesting an action. They won't say something needs to be done, like change a dose or monitor, but they will say that patients may be affected. In that case, it would be actionable, but no prescribing info. So that's how we are tagging them right now. Additionally, on that FDA list, there's a lot of kind of non-traditional, non-germline PGX. There's a lot of oncology stuff. We've known that for a long time. We have this cancer tag. But in the past, we used to consider any drug for which a genetic variant was the indication for the drug to be used to be under the testing required category. But as that list grew, it didn't seem really appropriate anymore. In a lot of cases, the label doesn't discuss testing at all. It's just a genetic condition, it's a drug indication. So in the past year, we came up with this new indication tag to highlight these. So also in the past year, we updated the definition for informative to now include labels that state that something is not related. There are some labels that say there's nothing clinically actionable about a relationship or there's no relationship there. So those are now under our informative, and we created this new tag, criteria not met, to be everything else. Which is stuff that doesn't say there's anything to do, anything not to do, and kind of makes you wonder why it's on that biomarker table. Okay, so that's our changes to how we do the drug label annotations. Briefly, I think a lot of us know that in 2020, FDA put out this table of pharmacogenetic associations with these 3 different sections. We've had information about this table on PharmG for several years now, but now we've formally imported it on PharmG. You can find this table and you can sort and search it. It makes it a little bit more usable in terms of finding specific information on PharmG, but the real reason why we put it in here is so that we could leverage it in some of our tools that I'm going to talk about in just a second. So we have a landing page for drugs sorted by ATC category, for which there's something actionable, either a guideline that says there's something that you can do, there's a recommendation for doing something for dosing or changing the drug, or there's something on the label, like I said, with prescribing guidance. So I went over what that was a little bit, or it's on that PGX associated table. So if you're just looking at like drugs, we want a list of drugs with some kind of actionable information from CPIC, DPWG, or FDA from one of either the label or the table, you can go to this page. But what if you want to be more specific and you want to know what's going on for a particular genotype? Well, we have you covered with our genotype selection interface. You can get to that from the homepage. This has been around for about a year now, but we have made some updates recently that I'd like to draw your attention to. So if you click that link on the homepage, you'll go to the tool itself. And we started with CPIC and Dutch information on it, but now we've integrated that wording from the FDA drug label prescribing section that we curate and from that table of pharmacogenetic information. We've also added the ability to enter a phenotype for a drug if you don't want to enter a diplotype, for example. You just want to know about intermediate metabolizers. I will say that the phenotype actually splits out by if you go to the pull down menu, it's actually split out by activity score right now. So you do have to specify an activity score for genes like 2D6, 2C9, or DPYD. And that's because there's at least one CPIC guideline where the activity score within a particular phenotype leads to a slightly different recommendation. So we need that activity score to be specific about the CPIC recommendation in some cases, so we make it required. So here's an example of me using it, a screenshot. You can see I'm entering a diplotype for 2C9. You can see that the box, I hope you can see, that the box under the phenotype column is grayed out. You cannot enter both a diplotype and a phenotype for the same gene. You can only enter one or the other. However, you can mix and match across genes. So if I enter my diplotype for 2C9, I can also go to 2C19 and enter a metabolizer status. If I enter that, you'll see that, I hope you can see the slight gray in the diplotype box. So now I cannot enter diplotypes. I can do one or the other. If I change my mind, I can just click this reset button and it'll clear it all out for me and I can start over. So at the bottom of this page is a little button that says make report. And if I click that, then I go to my results page And just as a brief tour of the results page, we have the section where by gene, if you entered a genotype or a diplotype, we map to the phenotype. We are using CPIC mappings. That's one point that I wanted to make about the FDA information in all of our tools, including GSI. Right now, what is included is FDA information for drugs that have an association with a gene that's already covered by either CPIC or DPWG. And that's because FDA doesn't provide any kind of mapping information. We've mentioned that a few times so far today, that there's this mapping information where you go from like the star allele to the diplotype, and you have to know the function, and you go to the phenotype. Well, they don't provide any of that information. CPIC does, and to some degree, the Dutch group does as well. So we can leverage those mappings for the FDA stuff, but if it's not already covered, if it's a gene not already covered by CPIC or DPWG, we don't have the FDA information in these tools currently. You will still find it on the website, though, if you go to either the table or the label annotations, just not in this tool. Okay, so, and then down below, you'll see that we have 21 drugs here, again, listed by this kind of ATC category. There's 21 actionable for the specific genotypes and phenotypes that I entered. There's actually 69 drugs with some kind of guidance from CPIC, DPWG, or FDA, but that's, with any phenotype or genotype, and we're being very specific here. So with these entries that I have made, only 21. You can pop down if you find your drug of interest to the table, but otherwise, if you scroll down, it's in alphabetical order. So this tool retrieves relevant information from 4 different sources, as I mentioned: CPIC, DPWG, the FDA label, and the FDA table of PGx associations. And this tool enables you to compare across all these resources. These tags are the same tags I mentioned earlier: dosing, alt drug, or guidance. They just kind of give you a high-level sense of what kind of information that source has. And we're going to zoom in on an example, clopidogrel. So you can find out more about the recommendations by clicking these little plus buttons to open it. I'm going to show you that in just a second. But here for clopidogrel, you can see that mostly everybody agrees that if you are an intermediate metabolizer, which is what I put in, then you need an alternate drug. However, you'll see that in this column, it says that there's nothing about that on the label. And that's because on the label, they definitely call out poor metabolizers, but they actually don't say anything about what it is to be an intermediate metabolizer on the clopidogrel label. And so you can see that here. If I click those little pluses open, you can see more information about each recommendation, and you can always trace back to the actual annotation, the original guideline, and the original drug label. So the GSI is great for comparing across those sources. And it's great on a big computer monitor where there's a lot of space and you can spread out and see everything, but it's a little clumsy for quick access to this information if you're on your mobile device. So, drum roll, we are introducing our newest tool to access this PGx prescribing guidance. This is a pre-release. You guys are the first people to see this. And in that sense, you're also our guinea pigs. So there's a QR code here. There's a link. You can please go ahead and go to that link if you'd like. I'm going to show you a little bit with some screenshots about how this tool works, and you feel free to follow along. And of course, you can always send feedback to feedback@pharmgkb.org if you find any bugs, or you have any questions, or you have suggestions, or you just really love it. We'd love to hear from you. So we are calling this new tool, I think I didn't say the name, DDRX. It is a DNA-driven prescribing tool. It has prescribing guidance. DDRX is a little bit long, so sometimes we say REX. This is powered by the information in PharmGKB that I went over with the GSI, and we have generous funding through Google for this particular project. Okay, so here is what the screen will look like if you go to this page. And I'm just going to show you that up in the right-hand corner, there's that little I. If you click that I for more information, it will take you to a page that has some information on it. We're still fleshing it out, but it has most all of the guidance there already, most all of the directions. If you scroll down this page, there is a section about installing this onto your device. So if you follow these directions, then you can get like, this is a mobile app. It's not an app from the App Store, but you can still put a little icon on your phone or your iPad that will be a direct link to this if you follow those instructions. And it's pretty cool. It has this like kind of dark mode. So if you're one of those people that likes everything with a black background instead of the white background, you can change it using the dark mode. And you can also go back to the home screen at the bottom with the button on the bottom. Okay, so you can search by genotype. It's the same kind of, it's pretty self-explanatory. If you search by genotype, you get these pull-down menus. You have to put two alleles. You go to view recommendations. And this time, what comes up is a condensed version of what you saw on the GSI. We have each drug, as you scroll down the page, you can see for this particular entry, there's allopurinol and rosuvastatin. So allopurinol, there's only a Dutch guideline. If I clicked on the rosuvastatin, it would pop me down to CPIC. I have a little arrow in the bottom right-hand side. It will pop me back up the homepage. On the screen, there's this little lines by start over. That is going to enable you to say, I want to rank my preferred sources. So if you enable that, you can get this screen where you see CPIC is always going to be displayed first if we have it. This is by default, then Dutch, then label annotations in the table. You can change that. You can use those little arrows. Say, I want FDA label annotations first. I'm going to push that all the way up to the top. I just keep clicking that little arrow. It's all the way up to the top. I hit save. Now it's going to show me FDA label annotations first if that's what I prefer, if they exist for what I enter. So if I go back to the home screen using the button at the bottom, now I want to search by drug name. I'm going to do something a little bit different. It takes me to this page. You can see each drug. You can see what kinds of information, which sources have some kind of information for that drug. You enter a drug like clopidogrel. I'm going to type that in. It takes me to, okay, for clopidogrel, you need 2C19. Tell us your genotype. I'm going to enter it. I put star 2, view recommendations. FDA label annotation comes up first. Great. Just note though, if I would have entered a star 1, star 2, I would not see FDA label annotations first. Why? Because I just said the FDA doesn't have any information about intermediate metabolizers. So CPIC was my second choice, and that's what's going to come up now. Okay. We have frequencies now from biobanks. We talked about this. Andrea mentioned this. Sorry, I wanted to say already. We have sources, like she said. We now have all of us is there, graciously provided by Philippe and Andrew Haddad from University of Pittsburgh, collaborated with us, and now they are up. This is brand new. You can see more information from that. We have our frequencies from Biobank, UK Biobank, both done through PharmCat. We also have information from the CPIC tables on any of our star allele pages. You can download all the frequency information from CPIC as bulk download Excel files. You can also bulk download UK Biobank frequencies from our downloads page. Okay, really briefly, PharmCat. I'm really out of time, so I'm just going to run through PharmCat here. This is our PharmCat homepage. Again, assuming that you know that PharmCat is a tool, PharmCat is a tool that will take a VCF file and translate it into the star alleles and then the diplotypes and the phenotypes. And then it basically works just like our GSI and our REX tool. But you start with a VCF file here. So again, PharmCat, we spent a lot of time getting up to date, staying current with CPIC and PharmVar. There were huge numbers of RYR1 alleles that were added through to CPIC guidelines through some ClinGen efforts. There was some newness with DPYD's HAPB3 variant. All those things are examples of how we update stuff. PharmCat now has DPWG guidance just like the other tools, and updates go along with that. For example, F5 was removed from DPWG guidance this past year. We also added all the FDA guidance in there. We have all the same tags in the report as the tags that I showed you on the other tools. We've also had multiple preprocessor updates for improved performance over the past year. We're up to 175 drugs with 18 genes with guidance. We can also give you guidance if you pass in genotypes for HLA-A, B, CYP2D6, and MTRNR1. Everybody knows for CYP2D6, you can't call it from a VCF file. You have to have BAMPs because of the structural variation. We've spent a lot of time improving our outreach, increased website documentation, videos on YouTube for how to run this. We've published a paper on it. We have a mailing list that now connects to the blog that Terry's going to tell you about in a minute. And we have user feedback through email and GitHub issues. We just published the UK Biobank stuff last year. We found some really cool stuff. We worked with Andrea and PharmG on some 4F2 allele frequencies and observed some of the same HAPI3 issues that were observed by others and published recently that Andrea highlighted. We were able to find a lot of allele frequencies in a lot of different populations that weren't already reported in those CPIC frequency files. This is the example. Some of these star alleles are seldom tested, but we found them in some of these populations at not negligible rates. In this case, we're looking at SLCL1B1 and allele star 31 over 3%, almost 4% in populations of African descent. And our upcoming projects, we're working with Stanford Healthcare to implement PGX in the hospital system using PharmCat and some long-read data out of PacBio. And we have collaborations coming up for inclusion of diverse populations through collaborations with Taiwan, Galatea Bio, Nomad. And all these frequencies, as we generate them, will be available on PharmGKB just like the others. And I'm turning over to Terry. Thank you.